All right, I think we can start. So I believe that people will be coming and joining uh, almost all the time because participants are in different time zones, but just not to be too much behind the schedule. Let's officially start the second QWorld Annual Meeting. So we had the first meeting uh, last year in 2025 in January as well, and today we are meeting for the second time. And this time the meeting will last 2 days. So tomorrow will be another session. My name is Pavel. I'm still the chairperson of the board of QBoard. I'm also the coordinator of the QCousins department, and I will first give you a brief introduction to this meeting, to this event, and QWorld in general. So the goals of this meeting is to present QWorld and its QCousins. There will be also discussions about the opportunities for quantum initiatives and further development of the quantum ecosystem, and of course, to integrate the QWorld's community. This is the agenda starting off from today. Times are in UTC, so I will soon give a presentation of QWorld. Then there will be the first part of presentations given by our Q cousins. First, we'll start from Q South Africa, then Q Hong Kong, Q Tunisia. Then there will be a break, and then we'll have the first invited talk. Jay Shah will tell us about quantum AI in the industry. Jagjit will be the chair, the moderator. Then there will be a second part of presentations given by our Q cousins, Q Algeria, Q Libya, Q Nepal, and then there will be another break. And then the second invited talk, Dr. Swati Mumandi will tell about the future opportunities for women in quantum, and Harsh Mehta will be the chair. And then Jagjit from QWorld, from the QCousins department, will tell about a new initiative that is called Q Next Gen. And Shalini will be the moderator. Then we'll have another break and the third part of the presentations. Harsh will be the moderator, and the talks will be given by Q Nigeria, Q Cameroon, and Q Lebanon. And then we'll conclude the first day. And it will not be the end because then they will have the breakout rooms in which there will be three breakout rooms with three interesting topics for discussion. So every participant could also share their ideas and opinions. So there will be a general discussion about quantum technologies, and Amit will be the moderator. Then Shalini and maybe also Harsh will give a talk about organizing workshops and events together. And then I will also moderate the talk about QWorld and QCousins. So we'll try to discuss how to organize, lead, and improve QWorld. Tomorrow we'll start half an hour later. So first, Abdul Malek will summarize the Q challenge, and Braulio will be the moderator. After the break, we'll have the fourth part of the presentations given by our Q cousins. So in this case, Gibran from the Q Education Department at QBoard will be the moderator, and the talks will be given by Q Italy, Q Canada, our newest Q cousin, and Q Bangladesh. Then there will be a panel discussion on the future of QWorld with several panelists. So beside myself, there will be also Gibran, Aritra, Aurel, and Harsh, and Jagjit will be the moderator. After the break, there will be another part of the presentations given by our Q cousins. Juliana from Q Italy will be the chair, and the talks will be given by Q Iran, Q Poland, and Q Brazil. And then there will be the third invited talk. Mariana will be the moderator, and the talk will be given by Guatami Sanyai Naik, and the title is Research on Quantum Natural Language Processing. Then after the break, there will be the last part of the presentations given by Q cousins. Shalini will be the moderator, and the talks will be given by Q Bulgaria, Q Egypt, and Q Saudi Arabia, also one of our newer Q cousins. We'll conclude the meeting, and finally, there will be discussions in the breakout rooms. The topics will be the same as today, so general discussion about quantum technologies, this time moderated by Abdul Malek, how to organize workshops and events together in 2026. The moderators are Shalini and Harsh, and then how to organize, lead, and improve QWorld and QCousins. So this time Mariana will be the moderator. If you have any questions, you can post your questions on this Zoom's chat, and our organizing committee members will try to answer. We also have the events Discord server. If you registered for this meeting, then you should have received the link to our Discord server. Uh, there is a channel named General Chat for asking the questions. You can also introduce yourself, and there are also some other channels for some discussions about keywords and so on. So our organizing committee wishes you a great event. So as you can see, there were more than 10 people involved in organizing this event and making it happen. So I would like to thank all the members of the organizing committee for their involvement. And on behalf of the organizing committee, we wish you a great event. I hope that you will enjoy it. So now I will tell more about QWorld. So as you have registered for this meeting, I believe that you can be one of the members of our QCousins or a member of our QWorld's Discord server. If at least you are interested in QWorld. So I believe that most of you are already familiar with QWorld and its activities. But just to summarize, QWorld is a global network of individuals, groups, and communities collaborating on education, implementation of quantum technologies, and research activities. So we work together, we collaborate together globally and operate locally, but sometimes also globally as well, to provide the open education to build or contribute to the development of the open global ecosystem for quantum technologies and democratizing access to education in quantum technologies. We have several initiatives. So since 2019, when QWorld was initiated, we've organized more than 200 events and handed out more than 10,000 certificates. So it's quite a good achievement. And QWorld is still growing. As you will see, we have more and more QCousins. I'm currently still the chairperson of the board. There is a plan um, to make the change of the managerial structures of QWorld this year. As if you are in QWorld for some time, then you probably know that we are also in the process of redesigning QWorld. But we'll probably keep our main merit departments, the QCousins department, Q Education department, and Q Research department. Beside QWorld, we also have a formal legal body that is behind QWorld's activities. It's called QWorld Association. So in this case, Aurel is the chairperson, and Maxims and Aga are also the board members. And initially, Abu Zareka Yilmaz was the, let's say, initiator of the association and its first chairperson, as well as the first chairperson of the board of QWorld. As I said, there are three main merit departments: Q Education department, QCousins department, and Q Research department. I can tell you that we are also now reactivating Q Women department. So Mariana Filipova is currently the coordinator, and she's trying to reactivate Q Women. So maybe in the next year, in the next QWorld annual meeting, we could also tell more about the Q Women department and its activities. But as for now, there are three well-established departments. Q Education department responsible for developing open educational materials and also organizing educational events. QCousins department responsible for entangling new QCousins and also staying in touch, staying in contact with our QCousins, collecting the yearly reports, monitoring their activities, and also supporting them, mentoring our QCousins helping them. And there is a Q research department, which is currently responsible or mainly responsible for organizing the Q intern program. I will tell more about the Q intern program soon. So in general, currently QWorld is still one of the largest quantum communities worldwide. There are more than 3,000 people on our Discord server. We have more than 30 QCousins. Not all of them are fully active. In some cases, we are looking for new coordinators, but we are still growing, and we have some plans for the next entanglement workshops and entanglement processes. So this is how we call this process of um, adding new QCousins to our QWorld community. As I said, we've organized more than 200 workshops and handed out more than 10,000 certificates. There are four main quantum computing courses that are called QPrep. So actually, this is a preparatory course that we sometimes organize before our flagship introductory level workshop QBronze. And there are two intermediate level workshops, QSilver and QNickel. But we also have some self-study modules, and based on them, we've also organized some workshops like QZinc, QCobalt, QMercury. And we hope that there will be more educational materials and more workshops, more types of workshops in the future. So, for example, for this year, we're also planning to organize a workshop on quantum machine learning. So there are some ongoing initiatives. We also have longer events like Q class or Q course. So more like massive open online course or the whole quantum semester online, of course. And we have the Q intern program organized by our Q research department. So every year we receive about 500 applications from students or generally people who are interested in research internships in quantum technologies. And we are planning to organize the next edition of the Q intern program this year. And there are many other quantum programs that we organized in the past or are still organizing. So, for example, Q Challenge is one of our new initiatives, and later today, Abdul Malik will tell more about this Q Challenge program. So in case of Q Education, as I said, we work together to develop open access educational materials and training educators to bring quality education, quantum technologies. Last year, we organized the next Q training to just prepare the next generation of instructors and mentors for our workshops. As I mentioned, Q Prep is our preparatory level workshops. This is basically a preparation um, for our more advanced workshops like QBronze, where we just give the basics of math like linear algebra and Python programming to just prepare participants for QBronze and other workshops. QBronze is our flagship workshop. It's an introductory level workshop when we just give an introduction to quantum computing from scratch. Um, and QSilver is one of these intermediate level workshops. It is focused on the Shor's algorithm and quantum Fourier transform. QNickel is focused on oracular quantum algorithms like Deutsch's algorithm, Bernstein-Vazirani algorithm, Simon's algorithm, and Grover search algorithm. Yes, so we also have these local groups in many countries. Currently, we have more than 30 QCousins. About 20 of them are quite active. They organize some events and every year, and today and tomorrow there will be presentations given by our active QCousins. We also have this research department that is focused on organizing Q intern program. So usually the application process for Q intern is launched around April, where we start collecting proposals for research projects, and then people from all over the world can apply to become interns, and we try to match them with the mentors, with senior researchers who proposed ideas for research projects. In 2024, we formally approved new principles, mission, and goals. So just to summarize, the current QWorld's mission is to provide an opportunity for free education, quantum technologies for people from all over the world, to popularize quantum technologies and their use, to enable research opportunities and contribute to training the next generation of quantum scientists, and to maintain a community of enthusiasts of quantum technologies and provide a platform for their communication and collaboration. So this is how we use our QWorld's Discord server. And QWorld's goals for the next years to integrate QWorld with the global open quantum ecosystem. So we try to participate in some international projects and collaborate with other organizations. So our goal is also to organize educational events like workshops, hackathons, and lectures. So as I said, we've organized more than 200 workshops. To have local groups, the so-called QCousins, responsible for organizing education and popularization of quantum technologies in their geographical regions like countries. And we would like to have at least 50 active and sustainable groups by the end of 2027. We'll see. As for now, we have about 30 QCousins, so close to 40, but there are a bit more than 20 active groups. We would like to have an active community of enthusiasts of quantum technologies sharing knowledge and contributing to discussions, in particular on Discord or during the meetings like today. To give QCousins the opportunity to meet virtually or in person at least once per year, like today and tomorrow during the QWorld Annual Meeting. To continue organizing the Q Intern program at least by the end of 2027, but I hope that we'll organize it even later because this is one of the most successful QWorld programs. To continue developing educational materials to achieve long-term financial and operational sustainability, as QWorld is a non-profit organization. It's not an easy goal. It's not easy to achieve this financial and operational sustainability. We would like to all be an active member of the global quantum community and to participate regularly in quantum related worldwide events like the World Quantum Day or International Year of Quantum Science and Technology that we had last year. We have several partners and established several partnerships. For example, we collaborate with Eureka in Adequate project, with Classic, with NUAT. We support the organization of the NUAT Quantum Hackathon. Unitary Fund was one of our partners and sponsors. Womanium Open Quantum Institute, we are a member of OQI, and universities and other organizations that our members are affiliated with. So, for example, this event is also supported by NITECS from South Africa. So they provided the Zoom platform for these meetings, and we are grateful for that, and we thank this organization for supporting us. So we also maintain several social media profiles and our Discord server. So we invite you to subscribe, to join our groups, to follow our pages, and stay in touch, to just stay up to date with all the events that we've organized. Okay, thank you for your attention, and let's check on our chat whether we have some questions about QWorld. Let's see. Yes, there is a question about one of the talks, recordings for meetings. So we are recording this event. So hopefully, if there are no technical issues, we'll try to just publish the recording on our YouTube channel. Yes, Qtitanium. About certification, no, in this meeting, no. So there's nothing to certificate, honestly. So Q Intern program, maybe there will be more information about Q Intern here. Aurel said that he would like to add a few comments. There's a question about applying for the sustainable groups. If you mean QCousins, then you can just try to contact our QCousins directly. There are dedicated email addresses for all QCousins. So you can just contact them directly to join, or if there is no QCousin in your country, you can try to establish a QCousin in your country, of course. Okay, Aurel, would you like to add some comments? Because you said that you have a few comments, so maybe you would like to unmute and give the comments now.
Yeah, great. Thank you, Pavel, for the very great presentation. It was a very good overview of what QWorld is usually doing in its general operations. I can add a few more things regarding specifically what were the developments for last year. So in terms of which collaborations we had, I think it would be very nice to mention that one of the when it comes to how QWorld intends to how we started to operate and how we intend to operate in the future is look for sponsorships for grants, and what we also do is we provide preparation workshops for different hackathons. So the OQI membership was a very good opportunity for this. This has definitely created some income for QWorld that we can then use for improving what we can provide to all of the QCousins and all of the members. And specifically, if we want to name universities that we worked with, we worked with the Columbia University, the City University in New York, the New York University in Abu Dhabi, and we have also become an associated partner to the DGQ program, which is Europe's quantum flagship project for master's education. There are 26 European universities, and QWorld is able to provide these open source workshop materials that we have been developing. And this is with this way we are able to give more visibility to what QWorld has been doing, and let others pick up on these materials and use it in their education. And you mentioned the adequate, so that was the name of the project that we did together with the Cureka. This was supported by the European Institute of Technology. So we have just submitted the final reports. I will still have to, those of you who are included in Adequate, you will still get one more task from me because we have to submit the timesheets. So we have completed this project. We have developed, I think, approximately 5 new modules that we foresee to be developed into brand new workshops, or some of them are perhaps already being tested in Q Turkey, the one on optimization. And this has definitely gave us a lot of expertise on how to manage and report on European grants. And we look forward to more European grants. We have been a full beneficiary for the upcoming European Quantum Academy. This was a proposal that includes 71 European partners, and QWorld is going to have a budget of 100,000 euros for 4 years. We still have to find the co-funding. And basically, the message that I want to give here is that QWorld is going to have a lot of opportunities, and being member of this global community, if you are able to show your skills and your dedication and commitment, then it is possible to be participating in this project. In the Adequate, we had people from all over the world, from Kenneth from Nigeria, Claudia from Mexico, Gibran and Razin and Mahnur and sorry if I can't remember everyone's name, from Pakistan, from Poland, from all over the world. So the QWorld Association has come up with a scheme how we can actually compensate financially people who participate in this project, and we intend to continue this in the future. So I think that QWorld can offer a lot to people who are active and want to be part of this adventure.
Right. Thanks, Aurel. Yeah, I think that we've already answered all the questions here. If not, then we'll just try to answer on the chat, but we are already slightly delayed, so move forward to the first presentation that will be given by one of our QCousins. We'll start from Q South Africa and Omid. So Omid, if you
Hi.
are ready, you can
Yeah.
share
Can
your
you hear
screen.
me?
Yes,
Fine.
yes, I can hear you.
Okay. Okay. Perfect. I will share my screen now, but just I think you just checked the chat, but you didn't check the Q&A part because there is one question.
Oh, there's also
Maybe you,
Q&A part. Okay, let
yeah,
me check it.
because just it's just one question. Yeah.
I will try to check it and answer there.
Sure.
Okay, thanks.
Perfect. Okay. Let's just okay. Can you see my screen? Sure.
Yes, I can see your screen.
Okay. Okay. Hello everyone. My name is Omid. Some of you probably knows me based on our activity on QWorld. I'm founder of Q South Africa. My presentation will be short and sweet because we're not as active as we used to be in 2025. Uh, so as Pavel mentioned, QWorld has some partners, and one partner, which is specifically uh, we as a Q South Africa are working with, is Nitex. Pavel. So next time you can say Nitex is much easier than Nitex. And we are working with Nitex, and we are collaborating with each other. And I will mention it in my next slide. Okay. We founded in 2023 with the, as you know, Entangling event. What we did this year, actually, one thing that I want to emphasize is for the first time, we had something which is called the NITEX Winter Internship, when we collaborate between, it was like a collaboration between Q South Africa and the NITEX, and it was in-person, basically event, and we invited people, student in the mostly honors level. Honors is the degree before the master's, to come into the Stellenbosch, which we are based actually, South Africa, NITEX and also Q South Africa. And we work on a specific project, which is basically is like bridging platforms from Qiskit to Penny Lane. And the reason was we realized that okay, every time we need there's a lot of deprecation in the modules, in the function or different things in Qiskit, and we thought maybe it's a good idea to have the similar Q bronze material, but in the Penny Lane, which usually does not that kind of lots of deprecation. So it was like intensive short, like 1 week in July 2025. And if you are interested, you can, I'm sure that we will share these slides after that. But if you are interested, I wrote a blog here, what happened during that internship, then you can read it. And also there is a GitHub page that yeah, it was 6 months ago, and we didn't finalize it because it was a short internship. So if you are interested, just let me know. Then we can basically proofreading and check all these notebook, and hopefully in the 2026 we can consider this as a standard, not a version of the Q bronze in Penny Lane, which is good. So these students learn a lot. They had to learn both Qiskit and Penny Lane and all those quantum computing material as well. Another thing that we had in the partnership with the NITEX, there was there was a mini school. It was a hands-on introduction to quantum computing with Penny Lanes, which is here after, and then when you have slides, you can check out. It's yeah, it's here. It's like 3 sessions, um, um, hands-on on quantum computing. It's just a basic material, but there are some overlap between this and the Q bronze as well, but some other material as well. And this is not exactly Q quantum computing, but of course, but it's still under the umbrella of quantum. There is nice mini school based on the quantum biology, which is another flavor of quantum. And if you check our YouTube channel, you can find a lot of useful lectures. Yeah, you can check, and there are lots of lectures, but specifically, I encourage you to check this one by Matthias Treuer from Microsoft about the quantum future of computing. So hopefully 2026 we will have more event, but for 2025, these were our basically activity. And before I finish, because before I need to mention just a few words about Q Iran. Before I established Q South Africa in 2023, we established Q Iran in 2022, and they are supposed to give a presentation tomorrow. I'm still not sure that tomorrow they will have internet connection or not, but by today it's around 9 to 10 days which the internet is fully shut down in Iran, and I don't have any idea. I text them on WhatsApp, Telegram, and I don't have any idea what's going on in Iran. So hopefully by tomorrow they will have internet. Then they can present what Q Iran did. Thank you very much for your attention, and I'm gonna unshare my screen, and the next speaker can share the screen.
Thank you. Thanks, Omid. Thanks for presenting Q South Africa. And now it's time for Q Hong Kong, one of our recently entangled Q cousins. Do we have a speaker from Q Hong Kong?
Hello?
Yes. Hi.
Yes, can you hear me?
Yes, we can hear you.
Okay, I will share the slides.
All right, great.
Okay, sorry. Oh, sorry, I will exit for a moment. For the app has some wrong. Sorry.
Okay, that's fine. Let's wait. All right, we are still waiting for Q Hong Kong.
Okay, sorry for the late.
Mm-hmm.
Okay, I'm going to share the slides. Can you see?
Yes, I can see your slides.
Okay. I will start. Okay. Hello, everyone. I'm here to introduce Q Hong Kong, our Q cousin community, and to share a short update on what we did in 2025 and what we plan for 2026. I will go through 6 slides, who we are, our 2025 statistics, and our input and contributions, our plans and goals for 2026, and a few additional notes for collaboration. Okay. So Q Hong Kong is a QCousin organized by quantum computing researchers and educators based in Hong Kong. We officially entered the initialization phase in 2025, and our first major step was to organize an entangling workshop, QBronze 169, to connect local learners with QWorld's global open education ecosystem. Our approach is simple. We want to make the entry point to quantum computing more accessible, especially for students and early career learners, and then gradually grow a stable local learning community that stays connected to QWorld's global programs. On these slides, you can see our coordinator, Shenfeng Cao, and our active members, Zheng An, Yongcheng Ding, Zipeng Wu, Yichi Zhang, and Xuanran Zhu, who helped make the first year of activities possible. If anyone would like to connect or collaborate, our website and the contact email are shown on the left. For 2025, our main QWorld related event was QBronze 169, held on 30 to 31 August and 6 to 7 September 2025, and we issued 79 certificates. We were happy that this first workshop created a concrete outcome and also helped us identify a core group of learners and volunteers who want to stay involved. Besides the workshop, we focus on building the foundation for continuity. We launched the Q Hong Kong website as a stable entry point, and we built a moderate, WeChat-based learning community where learners ask questions, share progress, and support each other. We also try to connect Hong Kong learners with other QCousins through cross-community sharing so that local participants can see more pathways beyond a single event and feel connected to the wide QWorld networks. This slide summarizes our contributions to QWorld in 2025. First, on the Q Hong Kong, we contribute through local coordinate, organizing communication, onboarding, and keeping the community active during the workshop period. Second, for mentoring in QBronze 169, we relied on volunteer mentors from Q Hong Kong community. The mentoring was mainly focused on helping participants stay on track, supporting them through the assessment and resolving common technical or conceptual issues when they come up. Third, for community building, we recruit and onboarded participants through local university channels and online outreach. We also manipulate a shared knowledge base, an FAQ, troubleshooting notes, and recommended resources so that the support effort becomes easier to scale and easily to reuse for future workshops. Overall, our main input this year was to establish a repeatable progress, outreach, onboarding, learning support, and follow-up community entanglement. Looking ahead to 2026, our main goal is to strengthen Q Hong Kong as a stable learning community and expand our local impact while staying tightly connected to QWorld's global programs. The first plan is to run a regular online event series, our Quantum Study Night, with rotating themes such as circuits, entanglement, noise, algorithms, and QML. The intention is to keep participants engaged between workshops and to form consistent study habits and peer learning groups. Second, we plan to build a local partnership network with university groups, student societies, and research labs in Hong Kong, so that we can reach learners more systematically and create a stable pipeline of participations and volunteers. Third, we aim to organize at least one workshop, either another Q bronze or a follow-up such as Q silver, Q nickel, or a QMR related workshop, depending on mentoring availability and community interest. Fourth, we want to establish a mentor pipeline, encouraging strong participations and certifications holders to become teaching assistants and further mentors, so the community can grow more sustainably. Fifth, we plan to collaborate with other QCousins in Asian Pacifics for joint sessions, guest speakers, and cross-community events. And finally, we aim to have at least one more person become active at Q Hong Kong, so that responsibilities and continuities don't rely on a single coordinators. To close, here are a few additional points. We are open to organizing events in collaborations with other QCousins, joint workshops, guest lectures, and shared mentoring sessions are all welcome. We also plan to publish wide community outputs, slides, short notes, and code notebooks, so that each event leaves reusable. Learning access and lowers the cost of organizing future activities. And we welcome mentors, speakers, and partners in Hong Kong and beyond, especially those interested in education, outreach, and building sustainability learning communities. So thank you for your time.
Great. Thank you. Thanks, Zeng, for presenting Q Hong Kong. Okay, and now it's time for Q Tunisia. Do we have a speaker from Q Tunisia with us? I'm not sure if there is a person from Q Tunisia. So actually, just recently we re-entangled Q Tunisia. There is a new team coordinating Q Tunisia, and they applied to give a talk, but it's possible that they didn't join. So I propose to move forward, and maybe we can come back to Q Tunisia later. I will try to contact them and ask. But according to our agenda, we should start the first invited talk exactly now. And this should be moderated by Jagjit. So Jagjit, if you are ready, I think you can start this session. And I will try to, in the meanwhile, I will try to contact you, Tunisia.
Yeah, sure. So basically, this was the first invite talk for today, but the person who was going to give this talk, Mr. Jaisa, due to some unexpected reasons, cannot give it live. So he has shared the recording for that session. So I will just play it. And if you have any question, you can you can ask on the chat, and the team will try to respond it as quickly as possible. Just let me know if my screen is visible.
Now I can see you.
Okay.
Hey everyone, thanks for inviting me for this session. And I couldn't really make it live due to certain unforeseen reasons, but I'm preparing this, session beforehand and sending it to you guys. And if after the presentation, if you have any questions, please do reach out to me on LinkedIn, and I'll be really happy to answer all your questions. So I'll share my screen and let's get started. All right. Okay. So yeah. So a little about me. I'm Jay Shah. I'm founder of QRL. That has focused on reinforcement, quantum reinforcement learning, quantum and classical. And we recently launched QRL QAI, which is a framework, pip installable Python framework focused on reinforcement learning. And I'm also a quantum machine learning researcher at BQP, which is a startup headquartered in New York. Besides my professional work, I'm a YouTuber and a podcast host. So if you're into quantum machine learning, please do check out my YouTube channel QRL, where I've put up a lot of stuff on quantum machine learning. A little more about myself. So the work I do at BQP, as I discussed, I'm a quantum machine learning researcher, and the focus here is on engineering simulations. We already have our product BQ5 out there. It's already launched, and if you are someone who is into computational fluid dynamics and related areas, I would highly recommend you go out there and check it out. And besides BQP, at QRL, the focus is completely on reinforcement learning. And as I discussed, I did create an open source SDK QRL QAI, which is again a quantum reinforcement learning and classical reinforcement learning based Python SDK, and you can simply install it with pip install QRL-QAI. And one of the environments is right now what you're seeing. So right now it offers 5 environments, encompassing multiple aspects of quantum computing, like compilation, error, noise, expressibility, a lot of things there. So there are a total of 5 environments, and more updates are coming really soon. So that's a little about my background and the work I do. As for today, the agenda is to give you the perspective of quantum AI in the industry, and we will start with an overview of quantum AI, a bird's eye overview of quantum AI, of what are the different aspects of quantum AI, and how is it really going on in the industry. Then we will come to quantum neural networks, where we will do a side-by-side comparison of classical neural networks and quantum neural networks. Because quantum neural networks form the base of the gate model quantum AI. They are a very important part, and that's why I'll focus a little more on that part, and so that just to make sure everyone is on the same page. Then I'll discuss about quantum computer vision and quantum NLP. Reason being, I see a lot of people looking into these 2 aspects of quantum AI in the industry. So I'll try to highlight those specific points for each one of these areas of quantum AI. After that, I'll focus on my research, the research I have done and published in quantum machine learning, which is again comes for physics informed machine learning, which is not a very popular area of machine learning, not a very popular branch of AI, but a branch which is very, very new and has a lot of potential. So I'll cover the basics of it, and I'll also cover then my publication and the results I published. Quantum physics informed machine learning, whatever work I've done, its significance for the industry and quantum machine learning itself. I'll touch upon those points, and that would mark the end for the session. All right, so without wasting any time, so quantum AI, as you see on the screen, can be so this is quantum AI, and I like to bifurcate it as quantum machine learning, quantum deep learning, and quantum reinforcement learning. This is not a very hard bifurcation. There are other ways of doing it, more precise way of doing it. But the reason I like to do it this way is, because of certain distinctions that each of these class of algorithms have. So coming on to that, for example, quantum machine learning. A general idea that you would see here in these types of quantum machine learning algorithms is that there already exists a classical machine learning algorithm, and what you would see is that the quantum computing ideas or math would be just used to enhance that existing classical machine learning algorithm. So an existing classical machine learning algorithm exists, and you're just using quantum computing to make it more efficient, make it better, right? Uh, and two good examples of that are quantum SCM or quantum support vector machines. And it's a big belief in the quantum industry that quantum support vector machines would most likely be the first quantum machine learning algorithm to show any sort of quantum advantage because of the kernel trick and the ability to utilize properties of quantum computing in there, right? So that's a supervised technique. If you like the second one, which is the unsupervised technique, which is Q means clustering, and this one's the quantum counterpart of K means clustering, right? Again, the idea is same. Even this algorithm that make K means more efficient by using quantum there. Now, if you see the box beneath it, this yellow one, I've highlighted it in yellow because all the other things that you're seeing on the screen are gate-based quantum AI, but the yellow one is actually annealing-based quantum machine learning, right? So these are two different quantum computing models, and the AI that will primarily focus today is quantum AI, gate model-based quantum AI, but there's more to quantum AI. I just want to highlight that. And QBoost, if you're familiar with classical machine learning, you might be knowing XGBoost, right? QBoost is a sort of that class of algorithm, the quantum variant of those class of algorithms. And quantum Boltzmann, again, if that already exists Boltzmann, algorithm in classical machine learning, quantum Boltzmann is the quantum version of that. But just to recap, in quantum machine learning, there already exists a classical machine learning algorithm, and with quantum computing, you are just trying to enhance that algorithm, make it more efficient, make it better. Now, if you come to quantum deep learning, it's a completely in the quantum deep learning algorithms will be completely different from the existing classical deep learning algorithms. Substantially different. And we'll see that you will see that when we'll go to quantum neural network. But the base ideas could be common. So in quantum deep learning, the ideas are borrowed from the classical, deep learning. But the architecture in itself and the other governing recipes are way different. The working and everything is way different from the classical counterpart algorithm, right? We will see, the quantum deep learning part in more detail. And just to highlight that, quantum computer vision and quantum NLP are the two areas that I'll discuss a little in more detail in today's session. Right. So coming back to the quantum reinforcement learning part, quantum reinforcement learning is my favorite branch in all of AI because it has a lot of potential. And if you are again familiar with reinforcement learning, I would say there are just two ways to make any reinforcement learning setting go quantum. One is to make any of the component of the reinforcement learning go quantum. So the basic idea in reinforcement learning is that there is an agent in the environment. Agent will keep on taking actions, and environment will give reward. So a good action gets a better reward, a bad action gets a bad reward. Eventually, agent will learn from the actions and it will solve the environment. That's the basic idea. So what you can do is either you can have the environment as quantum, so that is also quantum reinforcement learning, or you can have your agent as quantum, so that is also quantum reinforcement learning. So that's one way of doing quantum reinforcement learning. The other way around is to have the quantum algorithm, so quantum counterpart of the classical reinforcement learning algorithm, like the QQ value that you're seeing here, right? So there are two ways: either change any of the component to quantum, or use the quantum counterpart of the classical RL algorithm, right? Uh, and if this interests you, please do check out QRL QAI. It's more detailed. It will be more helpful to look at what a quantum environment sort of looks like. So in the second slide that I showed you, the block sphere environment, that was a quantum environment actually, right? That was an example of quantum reinforcement learning. And as for just introducing agent in the picture as quantum, is simply using a quantum neural network. So if you talk about quantum neural network, let's get to quantum neural network. And in this slide, what I really want to do is give you a side-by-side comparison of a classical neural network, feed-forward classical neural network, and the equivalent quantum neural network. Okay. So the first one each network starts with the input layer. Now, just to make one thing very clear before I proceed, that this particular setting is assuming gate model quantum AI, and even in gate model quantum AI, I'm assuming the classical data quantum algorithm setting, right? There are different ways of doing that as well, but we are specifically focusing on classical data and quantum algorithm. Okay, so with that clarification, if you see this this orange boxes, they both represent the input layers in each of the respective neural networks. So on the left one, what you see highlighted in the orange box is the input layer for the classical neural network. I'm sure you've already seen this many times already. What you see on the right is basically the input layer for the quantum neural network. And the basic idea of the quantum input layer is to just convert your classical data into quantum state. That's the only way. That's the only objective here for the quantum input layer. And what you're seeing in the picture right now, I'm using angle embedding, which is one of the ways of converting the classical data to quantum state. But it's a very popular way of doing it, but it's not the only way of doing it. But it's one of the first choices that you generally make, right? Then the second part is the hidden layers. So again, on the left, what you see is the classical hidden layers. And on the right, what you see is one quantum hidden layer. Now, a quantum hidden layer basically has two parts. The first part is the variational layers, right? So this first pink block that you're seeing in the hidden layer, it's the variational layer. Why variational layer? Because it has variational unitary gates. And what you're trying to do here, if you see these 5 values, phi 1, phi 2, phi 3, these are basically your weights that you're trying to optimize over training, right? So this is the variational layer. Now, the second component of the quantum hidden layer is entanglement block, right? So a variational layer and a variational layer and a entanglement block together are termed as quantum hidden layer. And what you can do is, keep on repeating this yellow box, and that would be equivalent of stacking more quantum hidden layers, right? Another detail is that a lot of researchers like to omit this entanglement block. Why? Because the weights you're trying to optimize are just in the variational layer, right? There's nothing we are really optimizing here. So why to have it? That's the argument. And a lot of researchers like to keep it because entanglement is one of those properties that are that is difficult to simulate classically. So if your quantum neural network works out with entanglement, it's more likely that it will be difficult to simulate classically. Have the same result classically. It will be sort of most likely it would be more difficult. So that's why people like to have this. This is one of the reasons, more direct, straightforward reasons of why to keep entanglement in the quantum hidden layer. The final one, which is here it is just output node, and here it is the output layer for the quantum neural network. And if you have worked with basic quantum computing, you know that this is measurement operation. And again, the idea of quantum output layer is just the opposite to that of quantum input layer. So quantum input layer was converting classical data into quantum state, and what quantum output layer does is that it converts that quantum state produced at the end of the hidden layers into some classical values. So the classical value could be bit string or expectation values, probability vector, depends, but it would be some classical value, right? So this was like a very one-on-one comparison of a classical neural network and the corresponding quantum neural network. I hope this was clear. And on my YouTube channel QRL, there is a 5-minute animated video from which I took this slide. So it's a more detailed video with a lot of animation. So if you like this, then definitely go check that one out as well. All right. So coming on to quantum computer vision, computer vision is one of the industries that's looking a lot at quantum. I've personally worked on it as well, and because the industry is so large, people are experimenting with quantum, and one of the areas especially is the computer vision for medicine, medical imaging and all those things. That's one of the key areas I've seen people looking into quantum computer vision. Right. And what you're seeing on your screen right now is a pure quantum convolutional neural network. So I'll explain this before I go into the details. So if you recall a classical convolutional neural network, you will remember that the basic idea is that to look at neighboring pixel values and extract information out of it. That's the most simplest way of describing a classical CNN. Now, if you look here in this first quantum convolutional layer, you can see this is basically a variational unitary that is acting on neighboring qubits, right? So this is sort of equivalent to a filter being applied or the kernel being applied, right? If you see these unitaries are all acting on the neighboring qubits. So this layer is basically the quantum equivalent of a convolutional layer. Then comes the pooling. So if you remember from the classical CNNs, you do max pooling, right? So basically you take max of from the output that is that comes from the applying the CNN layers. What you do is you just take the max value of a grid, say from a 2x2 grid, just take the max value, which eventually basically reduces the size, right? And if you see something here, which the conditional measurement operation that is being done here, it is sort of an equivalent of pooling. So if you see up until here, the size was 2 qubits, but from here it's only 1 qubit that's going out. So it's just a way of reducing the size here, right? Now again, if you remember, after convolutional and max pooling, what you do is you repeat this block of convolution and pooling. So you see the same similar structure here, convolutional and again pooling. At the end, for a classical CNN, you have a fully connected layer, which is again the same thing that you see here. We are just using a normal variational circuit here as a fully connected to replace the fully connected layer. And then eventually here, the measurement is basically representing the output layer, right? So this is a pure quantum CNN. And besides this, you will see two other variants that people use in this quantum computer vision. One variant is just replacing all the quantum convolutional layers with classical convolutional layers. Why? Because your number of qubits is really limited, but the image sizes could be comparatively bigger. Right, then you will have to downsample, and that would result in loss of information and those problems. So what people like to do is that have the classical convolution layer, so there's no problem with the image part, but just have the final fully connected layer as quantum. So that's this second variation that people you will generally come across. The third variation is literally just the opposite. So you will have quantum convolutional layers, but the final layer would be classical. The fully connected layer would be classical. And the reason being that people like to see, because quantum and classical layers learn differently, the kernel learn could be different. So that's why people like to, what people like to do is have a classical convolutional with fully connected, and have a quantum convolutional with classical fully connected, and have a one-on-one comparison. So that's the third variation that you would see generally in the quantum computer vision. So these are the three prominent variation you would see in the quantum CNNs. Besides this, you would see people trying to do quantum version of YOLO and all those things, but the basic idea would be similar to these three variations that I just discussed. So that was quantum computer vision. Now, one very important aspect of quantum AI that I would really like to highlight is quantum NLP. So generative AI is in the boom. Everyone is into generative AI, which actually stemmed from natural image processing, and the classical field has propelled like anything in last few years. But so has quantum NLP, but it is something that's talked about less. So, and there are like fundamental ideas of quantum NLP that are not yet explored in classical NLP, or cannot be sort of explored in classical NLP. So for example, what you're seeing here is called a string diagram, which sort of shows the flow of information in a sentence. And this is a very quantum way of doing it. These ideas come from categorical quantum mechanics, created by Professor Bob. So, Professor Bob is a very important person who has done a lot of work in quantum NLP. He's the professor of physics at Oxford University. He's also the chief scientist at Quantinuum. And if quantum NLP interests you, there's also a SDK he created called Lambeck, which is spelled as LAMBEQ, and it's a very popular SDK completely dedicated to quantum NLP. And if you're looking for a very unique area in quantum AI, quantum NLP is the area for you. And industry applications, I don't have to tell you, this can have immense industry applications, right? So, and it's not a very easy field. It's a difficult field as compared to the other, branches of quantum AI. But this branch, this quantum NLP, has a lot of potential, and for research and for the industry. So, if this interests you, do check out the documentation of Lambic, and it will really help you to get started with this branch of quantum AI. All right, so that was all the overview of quantum AI. Now I'll start discussing my research in the subject, and before I do that, I'll just lay the groundwork of the classic.
Maybe we can move forward at the time is less. So, sorry. One second. Yeah, sorry for that. Maybe we can just move forward as we have very less time for the next event. So maybe we can have a break for 3 minutes. Then the second part for presentation by the other Q cousins we will start.
Okay, so we have a 3-minute break. Thanks, Jagjit.
I'm just gonna test my screen sharing quickly.
Yes, it's visible. All right. So we can start with Q Algeria first to present their presentation for the work they have done in last year.
Thank you, Jagdeep. I'm sharing my screen. Do you see this? Is the screen visible? Am
Yes,
I audible actually?
yes, it's visible.
Oh, okay. Okay, thank you. Mm. So, hello everyone. I am Muhaymin. I'm board member of Q Algeria, and I'm here to present our progress, what we have done last year, and show you what we aim to do in this year, inshallah. So, a quick introduction on QLJ. We were founded in April of 2024 by Dr. Professor Muhammad Tahar Wabah and his students at the University of Constantine 1. One of those students is me. And the Constantine Quantum Technologies CQ Tech Group. The founding team consists basically of theoretical physicists because the Professor Staha's group were theoretical physicists, and it is supported by also some computer science students specializing in AI. And with our new two members, this year's new two members, we have people who are not in AI, they are in computer science, and they do research in a lot of things. Our mission in Q Algeria is to bring quantum to Algeria and make people very aware of it. And it's something that we have enjoyed doing, especially this past year. So the chairperson of Q Algeria is Professor Muhammad Tahar Wabah, and the total number of active members is 9. We went up from 7 last year, and two new people have joined us. So what we have done last year, we started the year with a huge event in Quantum, which was QNexus. We organized it in February of 2025. It involved three universities in Algiers: the National School of Artificial Intelligence, the Algiers University, and the Houari Boumediene University. It involved working with a lot of student clubs, and we had 200 participants in total that registered. The event spanned through 3 days. We had the plenary sessions and talks by Professor Tahar Webah in the morning, and in the evenings we conducted workshops to teach students, focused workshops to teach students about quantum. We had we had four options for them to choose from, but all of them they ended up choosing only three options. We had material for quantum random number generations and quantum key distribution, and specifically for this event, we developed two other workshops that are quantum machine learning workshop, an introduction for quantum machine learning, and an introduction to variational quantum algorithms. These were developed in-house by Q Algeria and CQ Tech members, and they were first used in QNexus, and people really like them. We hope to develop them in the near future to make them official QWorld workshops. That is not done yet. In addition to that, we also participated in organizing the Tech Trend Days in a different university in the east of Algeria, Bouaghi University. The theme of the Tech Trend Days was from agentic AI to quantum computing. So there was one day on agentic AI, and the second day was on quantum computing. There were two talks. One of them was by Professor Tahar Webah, the chairperson of Q Algeria, and we also conducted two workshops on quantum key distribution and quantum machine learning with the students there, and they enjoyed it very much. We also, through Prof. Tahar Webah and through our members, we participated in the organization of the first workshop on quantum science and technology in the University of Mdia. It involved presentations from scientists in Algeria. It was not a hands-on workshop, it was more like a conference, but yeah, we supported that. And eventually in May, members from Q Algeria organized AI Quest, there was the original AI Quest hackathon that was done yearly, and we organized the quantum edition, the first quantum edition of AI Quest. It was the first quantum hackathon in Algeria, and I think it was the second quantum hackathon in the whole continent. It was organized in the National School of Computer Science in Sidi Bel Abbas in the west of Algeria. So our events kind of covered almost all of Algerian universities from the east to the west, and the QNexus where it happened in the capital in the center. Looking, the one good thing that we contribute to QWorld this year is that that is motivating us to work in 2026 is that now we have two Q Algeria members that are certified instructors to organize Q Bronze, myself and my colleague Abdullah Tunsi. This extremely facilitates because we had some challenges with some students back in QNexus that were Algerians, and they are young, especially from high school. They did not understand English exactly, and they wanted to have Q Bronze workshops, but we were not certified to do it with fully like we were not certified to do it officially through Q World in our own language, and having these certifications to organize Q Bronze is extremely amazing for the coming year. What we plan to do is we'll aim to reach a wider audience. We increase our reach, collaborate with more and more clubs, do more presentations, organize seminars to introduce quantum to all levels. Basically, we have for the moment, the main people who are knowledgeable or interested about quantum and Q Algeria and know us are students. We would like to expand that to more of the teaching or working people in the universities and the high school students too. We aim to organize at least two workshops. One of them will surely be a Q Bronze, and we hope to return the Q Titanium workshop in a second edition, and hopefully a third one where it introduces topological quantum computing. We aim to organize the next QNexus event and hopefully formalize it and maybe make it an official QWorld event with its own format, and create new education materials, adapt the ones we have to make them officially QWorld materials, and also create new education materials for new fields. That being said, we are open to organize some events with collaboration with QCousins. sincerely invite collaboration. And if you have any ideas, please reach out to us. We would love to contribute in any way we can. We have social media. Our main social media is LinkedIn. We have not established other social media yet because when we organize events, we mainly organize them through clubs, and they handle social media on. They have bigger platforms for their own students on other social media. We plan to be more active on LinkedIn and hopefully establish some other social media if it's helpful for that. Thank you very much.
Thank you, Q Libya. Q Algeria. Now let's move to Q Libya to present their presentation.
Good evening, everyone. Just let me share my screen. Is my screen visible?
Yes.
Okay. Let me just make it. Okay, I'm Omima Miftah, one of Q Libya, one of the Q Libya members. I'm so glad to participate in the QWorld Annual Meeting, and it's the first time actually for me to attending QWorld meetings. So before I get started and talk more about our activities in last year 2025 and our plans for 2026, I want to just to give a quick clue about our community. So, Q Libya is actually established in 2021, and our mission is to educate and engage the Libyan tech community with quantum computing by give them the high quality and world-class quantum education resources. Our community is still small, consists just of 19 members. Our heads, Mr. Abdel Malik and Mr. Firas Chita, Mr. Rami Harb, and Mr. Firas Misbah. Our plan for 2026 is to expand our network by involving new members to our community. So in the 2025, actually, we organized two main keyword workshops. The first one is Q Bronze 170, and this workshop, it was like an introductory level workshop. The number of participants were about 25 attenders, and during this fellowship, the participants gain a strong foundation about the quantum computing. And also, we delivered about 15 certificates to the participants who complete the tasks on Canvas successfully. And after that, we organized Q Silver 13. And this workshop, it was more practical as the participants gained the hand-on experience in quantum computing programming. And also, we delivered about 16 certificates to the participants who complete the tasks of this workshop successfully on Canvas. And also, we organized other activities and other talks in regarding the quantum computing. So one of these activities is actually was a lecture given by Mr. Abdel Malik, and this workshop, it was about the basic of quantum computing for the telecommunication. And also, Mr. Abdel Malik managed to convince the computer engineering department at the University of Tripoli to involve the quantum computing as a subject for the department course. So for that, he gave a lecture for 2 days about the basic of quantum computing for the department students. And also during the 2025, we organized a lecture for the Saraya Hamra University to educate the students also about the quantum computing for future computer and AI engineer. And also at the end of 2025, we launched our Q Coffee Corner series, and it was an informal and discussion-based event. It was super beneficial for the participants as they exchange their ideas and their information about the quantum computing and also about the up-to-date knowledge about the quantum and also their potential for different sectors. And in 2025, we managed to increase and we managed to raise the awareness and educate more than 100 Libyan youth about the quantum computing and quantum technology. We extended our impact beyond just one city in Libya by involving so many of organizations and universities from different cities across Libya. And also our community members were so active internationally, as some of our community members attended the Afrotech Intelligence Congress in Tunisia, and this event was for the AI and quantum computing for African innovation. And also some of our community members are organized and participated in regional events aligned with the International Year of Quantum Science and Technology for 2025. And also Mr. Abdel Malik attended and gave a lecture at the ELSA, Ethical, Legal, and Social Aspects of the Quantum Technology Conference in Istanbul. These are our main achievements in 2025. So as well, in 2025, our members are actually participated and contributed to the QWorld activities. Mr. Abdel Malik was the advisor of the Q training, and also Mr. Firas Cheat delivered an instructor certificate of a Q training, and also Mr. Abdel Malik, he will be the Q challenge presenters of the Q challenge for the annual meeting for this year. And our plans for the 2026 and main aim for 2026 is the growth. So for that, we want to reaching more individual, Libyan individual, and also to expand our community by involving new members, and also to increase our current, we increase the activity of our current members, and also we want to organize more advanced topics in quantum computing by organizing quantum fabrication and simulation workshop, and also we want to organize a quantum machine learning workshop, as well as we want to organize Libyan quantum hackathon. And as I said before that, the Q Coffee series that we launched at the end of 2025, it was super beneficial. So we want to continue doing more serious in the Q Coffee Corner, and these are main aims and plans for 2026. We hope we could to achievements at the end of 2026. And we are always looking forward to collaboration with the QCousins. And if you have an idea for a joint event, just you could reach out and to us, and we could find us on LinkedIn and Facebook. Thank you.
Thank you, Q Libya. Now let's move to Q Nepal.
Hello, am I audible?
Yes.
Let me share my screen. Can you see my screen?
Yes.
Okay, great. Good day, everyone. It's my pleasure to represent Q Nepal at this QWorld Annual Meeting. Today, I'd like to briefly introduce who we are what we have accomplished over the past years, and how we envision growing the quantum community in Nepal. Okay, Q Nepal is a Q cousin of QWorld, formed by a community of quantum enthusiasts, aspiring researchers, and educators from different parts of Nepal. Mm, our journey began with the organization of our first QRunes workshop in September 2023, which we conducted virtually. Since then, we have grown into a active community with over 85 registered members, guided by a really dedicated executive committee to promote quantum education and awareness nationwide. Savin Thapa is our coordinator, and we yeah. In 2025, QNepal actively contributed to QWorld ecosystem by organizing Q Silver 28 and some other academic activities. So overall, we had Q Silver and Q Tech series, which was about 13 quantum talk throughout the year. Okay, I'm sorry. Okay. During Q Silver 28, we had a participants of 177, among which 87 were graduated, and most of were from Nepal and India and some other nations, Iran, Pakistan, USA, Egypt, Turkey, and Bangladesh. And as a part of celebrating 100 years of quantum science and technology, we organized Q Talk series throughout the month. We had 18 talks and participants were from 3 different continents, 15 plus institutions, and the talk were actually based on the 7 different quantum subfields. And yeah, most of the students were undergraduate students, graduate, and some of were high school students. Okay, and okay, looking ahead to 2026, Q Nepal aims to deepen its impact through education, outreach, and collaboration. Our goal includes organizing quantum in school. So we are planning to make a course for the school students, and we'll continue our monthly Q Talk series. Also, we would like to organize a physical quantum hackathon in collaboration with some other national institutions or national organizations. And even we are very open to collaborate with some other QCousins. And as a part of QWorld provided courses, we are planning to do at least two workshop, either Q Bronze and Q Silver, or Q Nickel and QML workshop. Also, we like to get active in social platform to popularize the quantum computing over our nation, so that young people and other people involved in the profession would get more exposure to what quantum computing is, and to grow within the community. We are also planning to start quantum study session, so we can share what we learn and what we are researching on and other stuff. Yeah, that was short and sweet. Additionally, if we really want to communicate with us and stay connected, we are really active in Facebook and then in LinkedIn. Yeah, so that was from Q Nepal part. And for the part of collaboration, we are really active. We are really open to collaborate with any other QCousins. And yeah, thank you. Okay, thank you for your time. And yeah.
Thank you, Q Nepal. So we will have a break for 3 minutes. Then we will have second invite talk.
Hi everyone. Uh, so it's time for the second invited talk of the day one of the QWorld Annual Meeting. The speaker for the second invited talk, we have Dr. Swati Mumadi with us, and Dr. Swati is gonna talk about future opportunities for women in quantum. Let me introduce Dr. Swati Mumadi. So she is an associate professor in the Department of Computer Science and Engineering at BVRIT in India. She holds a PhD in quantum computing and cryptography from National Institute of Technology, Surathkal, India. And she has a bachelor and master's degree in computer science and engineering as well. She has over 11 years of teaching and research experience. Her research interests span quantum computing, quantum cryptography, quantum machine learning, and quantum key distribution. She has published more than 30 research articles in reputed journals, conferences, and several book chapters as well. She is also a Qiskit advocate and serves as an academic advisor to industry and actively mentors students while contributing as a reviewer to leading international journals and conferences. Dr. Swati, you may please share your screen and begin your talk.
Thank you, Harsh, for the introduction. Okay, I'll share the screen and start the presentation. Yeah, is my screen visible?
Yes, the screen is visible.
Yeah, am I audible?
Yes, you are audible as well.
Yeah. So, yeah. So, today I'm going to talk about future opportunities for women in quantum. So, I would like to just give a brief on what I'm going to present today in my session. So first we will be discussing why quantum. Like now, a lot of people are talking about the quantum, but what exactly the advantage we have the quantum when compared to the classical, and where exactly we had a breakthrough so that people started working on in quantum. I mean, the work has been started 100 years back as well, but it has been accelerated in recent years due to some breakthroughs. So we will discuss all those also in detail, and then we will see what are the different types of quantum systems we have, and what is the status of quantum systems that have been developed, and we will see what are the various applications we have, and then available real quantum systems as well, and what are the opportunities we have for the women in quantum in terms of doing some certifications, or in terms of job opportunities. It can be internships or placements. And also, what are the research opportunities we have, like research funds, what are available around the globe. All this we will discuss in detail, and also we'll see what are the future directions where we can concentrate on to continue our research. All this we'll discuss in detail in our session today. Okay, let me talk about why quantum first. So, as we all, like most of you are already aware that like RSA algorithm is one of the strongest security protocol, where like most of the security uh, wherever we require the security, and there we are using the RSA. For example, if we talk about the banking, or if we talk about the any confidential data, if we wanted to make it safer, so we will be applying some security protocols. So in that we have the security protocols like RSA or AES or ECC. All these are the protocols which we are using to secure our data. So where we will be using the prime factors, or it will, like RSA algorithm is depends on the integer factorization. So we will be having two prime factors. So if we could able to, like, it is developed by using two prime factors. If you could able to break that, then it will be easy to break the algorithm, and whatever the data we thought of like saving confidentially can be visible to everybody. So for that, like if you talk about the current security protocols, all are mostly dependent on RSA algorithm or AES or ECC. We have many security protocols where integer factorization plays very important role. But like even the current security protocols that are available are strongest ones, because if we talk about RSA 128 qubit protocol. Okay, so if I talk about RSA 128 bit protocol, so it has been divided into two prime factors of size, 64 bit and 64 bit. So whenever we talk about the binary information of 64 bit, there will be 2 power 64 possible combinations, right? So if we talk about two 64 bit prime numbers, then there will be two power 64 combinations, and from that we have to find out two possible prime numbers, so that, like, which can be used for breaking the RSA algorithm. So usually, if we use the supercomputers to solve RSA 128 bit algorithm to find the integer or the prime factors of that particular algorithm, usually it would have taken 10,000 years. So this is what claimed by the Google. But later on, even IBM said that it won't take 10,000 years, it will take 2.5 years. So let us stick to 2.5 years. So even though, like, even if we use the supercomputer to break RSA 128 bit algorithm, it will take 2.5 years. But whereas if we use the quantum computer, so this is just example of IBM quantum computer, how it looks like. So if you use the quantum computer, any of the quantum computer, okay. So if you use that, then it would have break that RSA 128 bit algorithm just in 200 seconds. So that is how it is faster. And this experiment has been done in 2019 by the Google. They have with their quantum computer. So in that, they could able to break RSA 128 bit algorithm just in 200 seconds by using the quantum Schwarz algorithm. So this is where we could able to see the advantage compared to the classical, and it's at the same time the existence of quantum will even even be a threat for the classical computation. It can be for the security, or it can be for the other applications as well. So if a quantum computer could able to break a security protocol where even supercomputer would have been taken a lot of time, then it will be obviously threat for even national security as well. Because entire security, like if you wanted to make any data confidential, that need to be encrypted and decrypted, and for that we will be using all the security protocols which are dependent on the integer factorization. So by using quantum computer, we could able to break that integer. We could able to find those integers within less time. Then automatically all these algorithms can easily breakable, so that the data will not be secure anymore. So this is where quantum has shown the advantage. At the same time, it also shown the threat that will be given to this classical computation. And let us talk about like why what a quantum computer can do when we compare to the classical computer. So as I told, by using the Shard's algorithm, we could able to break RSA 128 just in 200 seconds. So that is an advantage. So even by using the Shard's algorithm, we can even find the prime factors of the larger number, or larger bits as well. So that is an advantage where which cannot be done in classical computing, because the Shard's algorithm has been implemented by using the quantum principles like superposition, entanglement, and all this uh, like quantum mechanical phenomena, so which we don't have in classical computing. So this is an advantage, so which can be used which can be used for breaking the classical security protocols, and at the same time we can even make it much more stronger by using the Shard's algorithm. And we have one more advantage, that is Grover's algorithm, which we as which will be used for sorting a number, or any sorting an element. Or for example, if I wanted to search an element, usually we have the classical searching techniques, like we have binary search. And for that, like to apply the binary search, even we should have the data in sorted form. But by using the Grover's algorithm, we can search an element even in the unstructured or unsorted database as well, which will take just order of root and time. When we compare to the classical searching techniques, it is very less, and even it is faster even compared to classical security protocol. Classical searching algorithm. So this is also an advantage, and also we have one more advantage, that is unhackable communication. So in quantum, we have a phenomena called entanglement. So where two or more quantum particles will be generated with the similar properties. So with that, those will be connected through the air. So if I modify one entangled qubit, then automatically other can be affected or can be modified. So this phenomena can be used for transmitting the data. Sorry. Okay, so this phenomena can be used for transmitting the data. So with when we use the entanglement, what happens is, like I can have one entangled qubit with me. We can have it sender, and one more entangled qubit we can have at receiver side. So if I modify my entangled qubit, then automatically this affects the other one. So there won't be any physical medium. So automatically it will not be possible for a third person to hack the data. Even if they try to measure the data, then due to the like superposition and due to the no cloning theorem, its actual state will get disturbed. So with this, like at present, whatever the quantum mechanical principles we are using, that will lead to the unhackable communication. Even if anyone try to measure the data or try to observe the data, that can also be known by the sender and receiver, so that they can even cancel that communication and they can restart the other communication. So this is what we have the advantages compared to the classical computing. So we have Shard's algorithm, which can be used for doing the integer factorization, and we also have the Grover's algorithm, where we can search an element from the unordered database as well, and we also have the unhackable communication. So these advantages makes it different and also makes it strong, like efficient compared to the classical computation. And now let me talk about like the growth of quantum systems, or the growth in number of qubit when we compare to year. So usually we have the Moore's law, in classical computation, when we talk about the chip design and all, we will be talking about the Moore's law. According to Moore's law, every year the number of transistors on a chip will be doubled. But we also have the Cure's law, which will represent the number of qubit or the increasing of the qubit in terms of year to year. So if you see, this is how the it has been increased from year 2014 to now. So in 2014, like the people started working on 2 qubit and 4 qubit, but later on, like when we moved to the 2016, it has been increased to the 17 qubit system. And later on, the people have started working on the qubit, like higher order qubit system. So this is how the growth is happening. So like at present, if you see the growth, it is actually almost 150% growth is there every year. So this is how it is happening. So even in classical, we have the 100% growth. If you talk about like every year, it will be doubled. But even compared to that, quantum, the number of qubits every year, the system which we are developing is doubled with 150, or is like increasing 150% every year. So this is how the growth is. So if this is continued, then it will be easy to break even 2048 bit algorithms. Like we have security protocols, AES, RSA of 2048 bit algorithms, which are one of the strongest algorithms now, as we discussed earlier. So if I have a RSA 128 bit algorithm, to break that, it will take 2.5 years. Or if we talk about like Google, it will take 10,000 years. So now we are talking about RSA 2048 bit algorithm. So how much time it will take? Obviously, it will be more compared to 128 bit as well, because it is we need to find out two prime factors of size 1024, 1024. So when we take 1024 bits, then automatically it will be having 2 power 1024 possible combinations, right? So finding the matchable combinations from these two will be not possible with the classical computing. Even with the supercomputing, it will take lots of time. So if we come up with the classical, if the growth is in this way, then automatically we may easily break the 2048 bit encryption as well. So which will be a big threat to the classical security protocols. So this is how the growth is or the progress in quantum. And now coming to the, if we see the theoretical foundations and the development from year 1900 to, because in 2025 we have been celebrated 100 years of quantum computing or quantum theory, right? So it has been started in 1900 itself. So till 1981, 1982, it is mostly on theoretical part. Like people used to solve it, and we had a lot of mathematical modeling, and theoretically they have been proved it. But after that, the people started implementing single qubit systems, 2 qubit systems, 4 qubit systems, and we also have the annealers, normally analog quantum computers. So people started implementing, and people started even researchers started developing a new algorithms by using the quantum mechanical principles. Like we have the Deutsch algorithm, which has been proven the superposition concept, and we also have the Schwarz algorithm, Grover's algorithm. So these have been implemented, and later on, like the development has been a little bit accelerated from 2000 onwards. So because from 2000 onwards, the quantum computer, like first trapped ion based quantum computer has been implemented, and later on even superconducting based qubits have been implemented. And then we have quantum annealer, which has been implemented by the D-Wave. And then the companies like Rigetti, Microsoft, Google, IBM, all this started implementing their own quantum systems. So this is how it has been transmitted from the theoretical perspective to the development or the practical perspective. So now even it's still going on. So now even we have a lot of advancements in quantum research and even in quantum hardware development. And now, if we see the investment in quantum computing, so this is how it has been increased. So in 2013, if we say it is $8 million, but now if we see in 2020, it was like $417 million, but now in 2025, it has been doubled. So this is how the investment has been increased in quantum, because the people understood that we have a lot of advantages using quantum computing, and also it will accelerate whatever the applications we have been implemented till now. If we include quantum, or if we integrate quantum with those applications, it will give the better results than what we are seeing today. So that's why even companies started working on quantum, and even people started investing on quantum computing. So this is where there is a requirement, this is where we got to know that there will be a lot of opportunities in quantum, not only in research perspective, we also have in the jobs perspective, like if we talk about internships or placements, and also if we talk about any certifications, and if we talk about any startup, if we are planning. So all these opportunities have been started based on, like, by seeing the growth in investment, we could able to see the future in quantum. So we'll see like what are the even other companies that are working on quantum. So these are various, like at present the quantum has been divided into four clusters or four verticals, we can say. So in that, the first one is quantum computing, and then we have the quantum communication, quantum sensing, and quantum materials. So in quantum computing, we have the possibility on working quantum algorithms and complexity. Quantum complexity theory also one of the area where we can concentrate on, and we also have a possibility of implementing quantum software and hardware for various applications. And we can also work on hybrid quantum systems, and also we can work on quantum machine learning. So when we talk about the future opportunities, usually the quantum research has been divided into four clusters or four verticals. So where it has been divided into, and based on the based on the applications, it has been divided into four verticals. So the people who are working in quantum computing, they're working on optimized algorithms, and even they are working on reducing the complexity of quantum existing algorithms, and also working on developing new softwares like quantum softwares, quantum simulators, and quantum simulation tools as well. So this is where you can, like, we can concentrate on if you wanted to do the research in quantum computing. And if we talk about the quantum communication, as we discussed earlier, the quantum can be used for the with the help of quantum principles, we can have an unhackable communication at present. So that can be used in communication to make even once the quantum system come into existence, the as usually as we are using a classical system, then it won't be a safer, like classical communication won't be a safer. So if we integrate quantum and classical or quantum principles or quantum advantages with the classical, then we may make it safer even in the quantum environment as well. So in communication, as usual, like whenever we communicate the data, there is a possibility of getting errors. So there is a requirement of quantum error correction as well, and also there is a requirement of implementing quantum fault tolerant system as well. And also we have quantum key distribution, so where we can distribute the quantum keys instead of the classical keys, because the quantum data is unhackable. So if we transfer the data in that perspective, then automatically it will be unhackable, so it can be more safer. And apart from that, we can also concentrate on quantum networks and quantum internet. So this is where we have the opportunities in future. We can even look into in working on any of these areas based on our interest. And even coming to the one more with a vertical, that is quantum sensing. There's a possibility of implementing quantum sensors, but these are not same as the classical sensors. So classical sensors will read the data in terms of classical perspective, but we need to have a quantum sensors where it can have a data in quantum perspective as well. So for that, even we have the magnetometers, and there is a lot of researches going on in quantum sensors as well. So if any are interested in this area, you can even concentrate on various the applications that we have in quantum sensing as well. And we have also quantum materials. So if we talk about the quantum system or qubit, the quantum states or the qubits can be implemented, or usually qubits can be generated from the materials. We will be having the materials. We have superconducting material, or trapped ion based materials, or topological materials, photonic based materials. So which material we are using, that also affects the performance of a quantum system. Because if you could able to implement a qubit from photonic material, then the lifetime of that may be, maybe more compared to the superconducting material. And superconducting material will be effective for performing gate operations, whereas photonic material may not be that much effective. So we have some advantage with each material, and at the same time we have some challenges as well. So if we could able to, like, if any of you are interested in nanomaterials, or you have a very good knowledge on nanomaterials, then that can be useful for applying, or that can be, you can use for continuing your research in quantum materials. So these are the major areas that at present the people are working on in quantum. And if one could develop any of the novel algorithms for any of these research areas, or any of these methods, then that can be useful for the various applications as well. Okay, so now apart from these, we also have the research opportunity in post-quantum algorithms, like where initially, like when I started this slide, I was explaining, RSA 128-bit algorithm can easily breakable by the quantum shards algorithm, right? So either you can use the quantum cryptography to make it secure by applying the quantum principles and all. Otherwise, you can also strengthen the classical security protocols by complicate, or by even making more complex, like the mathematical modeling whatever we have for the classical security protocols. If you could able to make it more complex, then automatically that will lead to the that may lead to the quantum resistant security protocols. So that is where post quantum algorithms or post quantum cryptography has been started. So whatever the classical cryptographic algorithms we have, AES or ECC or RSA algorithms, all this can be easily breakable by using the Shor's and Grover's algorithms, which have been implemented by using the quantum mechanical principles. But if we could able to strengthen our classical security protocols by applying some mathematical modeling and make it complex, then automatically it will resist even quantum attacks as well. So if any are interested in post quantum, or improvising the quantum, like classical security protocols, or to strengthen the classical security protocols, we can even concentrate on post quantum algorithm development as well. And now coming to the application, so there are various applications where we can apply the quantum computing, and it will give the better results than what we are seeing today by using the classical computing. So the first one is we have the applications in artificial intelligence and machine learning. So the integration of quantum for AI and ML will accelerate the results whatever we are getting today by using the classical AI and machine learning models. And we also have the applications in computational chemistry. So if we talk about, in chemistry, we will be having a molecular designs, right? So whenever the number of molecules are more, then automatically to design or to find a proper combination or of those molecules will be more complex. So if we could able to apply or integrate quantum mechanical principles, like superposition can be used for getting the all possible results in a single run, right? So that can be useful for making molecular design easily, and also for the other chemical related applications, and also can be used in healthcare, drug design and development. So at present it is showing very good results in drug design, and also the development, like new drug designs and all, because as we discussed, with the help of quantum principles like superposition, it will be easy to design new drugs, where there will be multiple combinations we need to try to develop a new drug. So those combinations can easily uh, done by using the concept of superposition. So automatically we can get the better results in less time compared to the classical drug designing process. And also in healthcare, we can get the more accurate results than what we are seeing today. And also we have the applications in cybersecurity and cryptography, because as I told earlier, we have advantage of unhackable communication, and also we can even strengthen the security protocols by integrating quantum to that. So we have applications in that as well. And also it can be used in financial modeling, and even for the logistic optimization, like if we wanted to develop optimized routing algorithms and efficient routing algorithms, there we can integrate quantum to those existing algorithms so that it will work even better than what we are seeing today. And it can also be used in weather forecasting to find the proper, like even the accurate results of weather changes and all. And also it can be used in automotive industry. So if we talk about like automotive industries like BMW, they started working, or they started integrating quantum with the routing protocols. They're using that quantum phenomena, and they are checking whether it is giving better results. And that. So it is still in research stage, but even automotive industry is also trying to integrate quantum to the existing the methods whatever they are following. And apart from this, we also have one more application, that is quantum teleportation. So where we can even teleport the humans as well. So even it is also still in research stage. So if that will be succeeded, then even we can see the teleportation of a human. So these are all the applications that we have, and this will give the better results with the integration of the quantum. And even few already have been proven, like even in drug design, and even in chemical, like chemistry applications, quantum is showing the excellent results than the classical. So and still the same thing is still research is going on in other applications as well, and researchers are integrating quantum to get the better results than the classical. So theoretically it has been proven, but due to the current the currently available quantum systems are in noise intermediate scale quantum level, right? So with that we have the some challenges internally, that is like internal noise and error rates and all. So even though like if we could able to overcome those, we can even see the even more better results. But even the research is going on, so where we could able to prove it theoretically, and we are also making to prove the same thing by using practical perspective as well. So this is about various applications. So any doubts still here? This Okay. Okay, fine. So next we'll see the various quantum platforms, because we know that various what we say like applications we have. So it has been proven that integrating quantum will give the better results. But if we talk about various quantum platforms, so there are the quantum systems that are available worldwide, and there is also access to like a few companies, or a few quantum, like few companies also giving the cloud access to their quantum systems. So let me talk about the quantum platform. So these have been divided based on the materials what we have been used. So what kind of qubits that have been used for implementing or performing various applications. So we have the quantum platforms that have been provided by the companies IBM, Google Quantum, and Rigetti. So these quantum systems are developed by using the superconducting material. And next we have the IonQ and Honeywell platforms, where even we have the access to their quantum systems, cloud access. So here the quantum systems are developed by using the ion-based or trapped ion-based
Excuse me,
quantum.
Dr. Swati.
Yeah.
Sorry to disturb you, but we are almost at the end of the talk. So could you please wrap up in maybe 1 2 minutes?
Okay, fine. So these are various quantum platforms we have, so which we can use for implementing various or whatever the applications we have been discussed earlier, those can be implemented by using any of these platforms. So based on the material that we are using, like even as I told, like we have superconducting material, ion-based material, and photonic-based material. So based on that, the quantum systems have been differentiated, and these are all the various systems that are available. And apart from this, even new platforms also have been included. So even you can look into like any of this platform for doing your experiments. And these are all the available quantum computers. So even now companies are working on a quantum system, or the quantum processor with high-end quantum like qubits. And this is how a quantum system looks like. So this is a annealer representation, like D-Wave have a quantum annealer, and this is IBM's quantum system, superconducting qubit quantum system. And now coming to the leading research institutions worldwide, many institutions have started working in quantum long back. So we have institutions where we have a particular facility related to the quantum. We have the hardware equipment over there, so you can even try visiting those institutions if you wanted to work on quantum hardware. So these are some institutions, but apart from this, there are many other institutions that are working on quantum globally. And these are some certification programs, and which even QWorld is providing QBronze diploma. And apart from that, even many other companies and institutions like US World Ranking institutions, even in India, IITs and NITs are providing the quantum computing certification programs. So I mean, all the certification programs are with theoretical perspective as well as experimental perspective. So even you can try, registering any of the certification as well. And now coming to the internship placement. So there are many internships and placement opportunities that have been given by the leading industries and leading institutions around the globe. And now, if I talk about the research and funding opportunities around the globe, so there are the awards and some funding opportunities which are especially supporting the women in quantum. So one is like we have a spy like SPY ICFO Fellowship Award, which is supporting women in photonics and quantum research. So it has been given by the Spain government. And then we also have the women in quantum optics, where they are providing the opportunity to the postdoctoral with the fellowship. So it has been given by the Max Planck Institute of Quantum Optics. And we also have the women in quantum scholarships and community support, so where we will be getting the scholarship to do the research, and even there will be a support for mentoring, like mentoring support will be given. So, and apart from that, we also have the Humanium and Wiser Global Quantum Launchpad and Fellowship Awards, where they can, fund the women in quantum for continuing their research. And even we also have the UNESCO Women in Quantum Science and Training Mentorship. So even they will provide the fellowship for that, even to continue the research in quantum science and technology. And we also have the QSC Women Focused Awards and funding. So these are all specifically designed for the women in quantum. And even there will be a lot of fellowships that have been provided to even those fellowships can be used for continuing the research, and can be used for the travel grant, and can be used to purchase equipment related to the quantum research. So all these are the fellowships and various awards that have been provided by the various research funding agencies around the globe. And we also have the international quantum and STEM outreach grants, and we also have the NSF grants that have been provided by the US, and even UK quantum fellowships have been given. So these are all the few funding opportunities that I thought of discussing here. But apart from this, many other funding opportunities that are available around the globe to accelerate the quantum research, and especially for the women in quantum. And these are the various companies that are working on quantum. So, like, even as I told, there will be different areas, different applications where we can concentrate on quantum. So, you can see your future opportunities in all these areas. Like, if you are interested in nanomaterials or quantum materials, you can work on various quantum materials. And if you are interested in quantum computing, you can work on developing softwares and hardware for various applications. And if you are interested in all, for example, if you are interested in any photonic based material, then you can even work on photonic based materials and photonic based quantum systems as well. So these are the few companies around the globe. But apart from this, there are many other companies that have been started, and they are working exceptionally well in the quantum research, and they are providing a lot of opportunities, or giving the priority for the women in quantum who are highly who have expertise in quantum computing and quantum communication materials and sensing as well. And now coming to the challenges and limitations, even though we have a lot of advantages and opportunities in quantum, we also have some challenges and limitations in quantum. The first challenge we have here is error correction. So as I told, the current available quantum systems are in NASQ level, like in the sense noise intermediate scale quantum level. So due to this, like we have by default, like all qubits are by default associated with the noise. So due to this noise, again, it leads to the decoherence, and also it leads to the high error rates. So if we could able to reduce this, then automatically it will give the better results than what we are seeing today. But it is a major challenge now we are facing, error correction. And we also have the limited qubit coherence time, so where the lifetime of a qubit is very less. So that is also one more challenge. So when we thought of implementing quantum memories and all, this coherence times will lead to the lot of difficulties, because if the lifetime of a qubit is less, then what will store in quantum memory? So that is where even we are facing difficulty to perform the operations on quantum bits. If you wanted to perform any operation for the longer time, then the coherence of that particular qubit, for example, has been lost, then whatever the data we have been stored in qubit will be lost. So this is also one of the challenge that we are facing today. And we also need the specialized hardware, because we cannot do the operations as we are doing in the classical. So we need to have specialized hardware to read the quantum data and also to perform the operations on that. And also, if we talk about the quantum machine learning applications, we need the data preparation. Like we need lots of data. So if I wanted to apply quantum machine learning models, if you could have a lots of data, then you can see the visible results, like, or visible the changes or the advantages compared to classical machine learning models and quantum machine learning models. So at present, even data preparation is one of the challenge, and also the algorithmic complexity. So we will be developing algorithms by using the quantum gates. So it will again will lead the complexity to understand the operations, how it is performing and all. And also we have the skill gap. So the people who are expertise in quantum are less based on the requirement at present, but it is slowly increasing. When we compare to 2 or 3 years back and now, it has been increased, but even we need more, because there are a lot many opportunities around the world. And if we could able to increase the skill set, then automatically the will be used helpful for developing various projects as well. And coming to the future directions, the women like who are interested in quantum, and the people like the people who are interested in quantum can concentrate on these future directions, where they can work on quantum hardware development. As I told, if you could able to develop some novel quantum error correction methods which can reduce the error rates in quantum system, then that will be a very good innovation. And even the companies or the institutions which are having the quantum system, they need the efficient error correction mechanism, so that it can reduce the internal noise and also the errors. And also you can concentrate on noise mitigation as well. And also there is a requirement of developing new algorithms, where we can develop for the quantum machine learning models for various applications. So even we can concentrate on that. And also we can look into hybrid models, like where we can integrate classical and quantum computing methods. And also there are various applications, even like climate modeling, robotics, and autonomous systems, where integrating quantum will be little difficult, but there will be a lot of requirement for that. So even that also can be considered for future research opportunity, as a research opportunity. And also the requirement is for the establishing industry-wide benchmarks and all. So these are all the various challenges we have, and at the same time, these are the directions where we can concentrate on. So whatever the challenges we have, those will be the opportunities for us to accelerate the quantum research further. So this is what about, like, I thought of covering the opportunities for the women in quantum, and this can be open for even everybody, all the researchers in the quantum as well. And in case, like, if you wanted to continue anything, so these are my contact details. You can feel free to contact me in case if you have any doubts related to any of the presented things. And any queries?
Dr. Swanti, thank you so much, first of all, for your talk. There was one question in the chat. If you are able to access the chat, then you may answer. Otherwise, we'll continue with the rest of the program.
Okay, let me check the chat. How do you mean the teleportation of a human teleportation? Yeah. Yeah, actually, what they are thinking is, like, we have a qubits are nothing but the particles. Previously, they thought of it as a wave, and the research is going on, it can be a particle. So, entanglement, if we talk about the entanglement, we will be generating the qubits in terms of the particles and all, right? So, even human body can be, it is a combination of various particles, and those can be used for transporting. So this is the phenomena that has been proposed, but we don't know how much it will be like exactly it will be useful for teleporting the human, because the research is still going on. but they could able to find that like some DNA issues they could able to find or they could able to face. But it is possible as per the theoretical perspective. So but when we talk about the practical perspective, there will be a lot of challenges as well. But this is what the researchers are saying, it can be possible in future maybe. But still research is going on the same. They are converting, or the human body will be divided into multiple particles, and those particles will be teleported from one space to the or one place to the another place. So this is what it is happening, and the example is for Doraemon. There will be anyway door, right? So we can move from that door to one place to any other place. So similarly, they can
Yeah,
even
well, I'm
trying to
sorry
tell.
to interrupt you, but I think this is a very, very problematic thing. I mean, there are a lot of
Correct, correct, correct.
misconceptions around quantum. There's a lot of
Yeah, yeah.
misconceptions, and 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 this is one of this is a very, very, very basic misconception that quantum teleportation would actually transport particles in any way, because that's not what's happening. These are the quantum states that are transmitted from one place to the other using entanglement. So unless we think that quantum mechanics is somehow underlying the basic life functions, then I don't think that we would ever want to use or ever need or want to use quantum teleportation for such a business. And this was just one of the things that I wanted to highlight from your presentation. Anyway,
Yeah,
thank you for
correct.
your
As you
talk.
said,
Yeah.
like there will be some challenges. As you said, it is
Yeah,
not
let's move
that
on with
easy.
the. I suggest that we move on, and because
Yeah,
we're late with the program. Thank you.
yeah. Thank you.
Thanks a lot, Dr. Swati. It was a nice presentation. And now we are going to talk about Q Next Gen. By the presentation is by Jagjit Chavan. Jagti, are you there?
Yes, thank you, Salini.
Yeah. So you're going to start, or are you just gonna give a small introduction about you?
We can start. We can start
Okay,
directly.
okay. Thank you. Please go ahead.
Yes, thank you. So, hello everyone. So, my name is Jagjit. I am been part of QWorld since 2024, and I have been the member of QWorld for organizing events. And last winter, I proposed an idea of Q Next Gen. So basically, as we have seen, there were some really good presentations by Dr. Swati and Mr. Jaisa. I need to propose an idea, like a general talk, to make a community around this, where participants from all over the world present their ideas. Like Dr. Swati presented the television of human, and oral gives like, okay, so is that even possible or not? So like this, the idea is quite to present the papers every year, which are published at the high level conferences. So we invite the researchers from that conferences to present their papers. We invite PhD students, MSc students. That's the one part of Q Next Gen. The other part is Q Women, where we specifically focus on the women contribution in quantum computing, like from a different perspective, like from professors to researchers in this field to the commercial side as well, startups organized by Q by the women's, from the communities led by women's. This is second part of Q Next Gen, and the third part is Q students. Sorry, Q juniors. Q juniors is basically for highest from the school perspective, like where we invite the students who are in higher schools, like to invite to build curiosity in them about quantum computing, so that we can have more participants in and more research oriented from that perspective. And then the idea was to held multiple events per week, per month, sorry, and where we invite the researchers from all over the world to present their papers. And we can also have multiple series going on with this. Like we can have, not depending on the what field we are presenting, it can be any field, like quantum computing, quantum NLP, AI, computer vision, and quantum physics as well, just to make sure that we invite high level students to present their before presenting any. Because what initially happens is we have a study material and we organize the events based on that, and then it's going on. Like we have entanglement, we have Q bronze, we have Q nickel, we have Q uh, cobalt as well. So my idea was to present something new, something innovative, where we don't stick to one particular material, but we invite peoples to showcase their ideas, to present their ideas as well, which look like give them which give them a stage to present their research as well. So we can have a we can have a different talks about that. Okay, is that even possible or not? So as Aurel mentioned early as well, like Q World is doing something like that in the Europes as well, by creating a curriculum about all of this. Like they have a project going on. So my idea was something like this. We create a community of all over this quantum computing, and we have we have a breakdown room as well after the talks. So if you have any ideas, if you have any questions, we can discuss there as well. So that was the main idea. We are thinking of planning of having the first session around late Feb or in the March first week, but we will post it on the different social media handles. The website is live on QWorld's website, so you can check out there as well. So along with me, I have Harsh Mehta as well, who is will part of that community, that idea, and Marina as well for the Q Women idea. And of course we will have another a very good team to have this idea, to make the idea a great place for peoples to present their ideas and research point of view. So that's what I want to tell and talk about Q Next Gen. If anyone has any questions, any suggestions as well, they can write in the chat, or we can talk about this later in the breakout room as well. Yes, that's what the initial thought was, this, like we can invite young researchers from different communities and countries, regardless of their what they are studying or what they are doing. They can present their ideas as well. We can have a general talk more than rather than a study room. We can think of a invite room where we have people from all over the communities to gather and sit and let, okay, so today's topic is this. If we have something like that, that's what I was supposing to present.
Does anyone have any questions to ask about? Jagjit, I think there is no doubts. I think you have cleared your ideas very structured in a structured way. Yeah, there is some question. Okay. No, I think. Do you have anything else to share, or
I think we can move on to the next part
okay?
of the meeting.
Perfect. Thank you so much. Thank you. You have conveyed your ideas very in a structured way, and it is very prompt and very quick. We really liked it, actually. Thank you, Jagdip.
Okay, it looks that the next session of presentations given by our QCousins should start in about 30 minutes from now, so maybe we can just take a break. I don't think we should start earlier, so let's just do a break until 6 p.m. UTC, or maybe there will be some other questions to judge it in the meanwhile.
Hi everyone. Welcome back after a brief break. So we are ready to start the very last session of the day first of the QWorld Annual Meeting. In this session, we have a presentation by three Q cousins. First presentation is from the Q Nigeria. So Ini, if you can share your screen and please continue.
All right. Hi, everyone. Let me share my screen. Thank you. All right. Please, can you see my screen?
Yes, your screen is visible and you are audible as well. You're good to go.
All right. Thank you. Hi, everyone. My name is Ini Ekpenyokut from Q Nigeria. I am here to present the activities for 2025. On my slide here, we have Q Nigeria. Of course, we all know we are QCousins, where we are being organized by quantum computing researchers and educators from Nigeria, within and outside Nigeria. We organized our first workshop in November 2021 in collaboration with the QWorld team, and we were officially initialized initialization phase in 2022. For 2025, we have organized different activities ranging from Cascade 4 Fest at the University of Uyo. That started 25th September till 8th November. It was an hybrid event. We had a total of 22 participants. Then out of that, we issued 7 certificates for those that did very well and 15 certificates for those that are still new into the field of quantum computing. Another activity we did was that we successfully integrated quantum computing course into the curriculum of the University of Uyo and that of Ibadan. Then University of Ibadan also organized Cascade 4 Fest. They had 20 participants, and out of that, about three participants successfully achieved certificate of achievement. Then we also had some of our new members from University of Ibadan joining the Cascade Advocate program, about 2 of them. Then within the year, we also had events organized in collaboration with IEEE at the University of Uyo, where I spoke on the topic, the role of information technology in the achievement of sustainable development goal in quantum computing era. In addition to that, we had series of talks in Q Nigeria that range from quantum algorithm, quantum key distribution, and photonic systems. 5 of our students or 5 of our members participated in the Pan-African Quantum Hackathon that that ended a few weeks ago. Then the contribution we've made to QWorld in 2025, we had Mr. Kenneth Isabade being a Q Education and a Q Cousin member. He has taught in several QPRONS workshops globally. Then I myself in him could be a member of Q Cousin department, which have supported or coordinated in the organization of some Q Cousins workshop. Example is Q Saudi Arabia and Q Qatar that is yet to start in few days from today. Then Based on our success in 2025, we have different activities that we have planned for 2026. We intend to reach wide audience through the appointment of quantum ambassadors in different high schools, colleges, and universities, so that we can be having direct contact with them, since most of us, some of us, are not in the university community, but to sustain effective participation of students and the university's members, we need to have quantum ambassadors that will monitor the activities, monitor and maintain the activities of quantum science and technology in the university or colleges, as the case may be. Then we also plan to organize Q prompts for some of our new members, Q Silver and Q Nickel. Then there's an event that we are planning the first quarter of this year. We'll call it Light Up Quantum. Uyo is a city. What do we intend to achieve? We intend to aim to bring together stakeholders to design a quantum roadmap for the state. Another activity, we want to sustain the Q Nigeria Quantum Series. In addition to that, we also want to now that we've successfully integrated quantum science and technology in the curriculum of some universities in Nigeria, we want to expand the reach. We intend to organize a quantum computing workshop in the University of Abuja, Akwa Ibom State University, and others. We intend to have at least 3 people being active in QWorld events globally. So we are open to organize some events in collaboration with other QCousins. So that's all from me from Q Nigeria. I don't know if there's any question or any comments. I would like to take it and note it down. Thank you.
Thank you, Ini, for your report on the activities of the Q Nigeria and the kind of activity you plan for the upcoming year. I don't think there is any question, and if there is any question, then you may approach on the given socials.
All right.
Okay.
Thank you.
Yeah. Next up, we have a Q Cameroon. So, is there anyone representing Q Cameroon available in the meeting? Any representative from Q Cameroon who can present? Yeah, I don't believe we have anyone from Q Cameroon. So let's move on. The last QCousins presentation for today will be from the Q Lebanon. And we have Ali Ibrahim with us from the Q Lebanon. So Ali Ibrahim, you may please share your screen and continue.
Good evening for everyone. Hopefully you are doing well. I'm Ali Ibrahim from Q Lebanon. Sorry, can you hear me?
Yes, you are clearly audible and your screen is visible as well.
Okay, about Q Lebanon, we are 5 students, researchers, and engineers who have a shared goal is to make quantum information and quantum computation available for everyone in Lebanon and all regions. And that's why we started Q Lebanon under QWorld. And let's go to the 2025 year. Basically, we gathered the teams from different places in Lebanon, from different regions and different universities. Sorry, and we built the team. Then we had our first QBronze workshop, which was in September 2025. We gave more than 30 diploma, and then we launched our social media on LinkedIn, social media account, so you can check everything that's going on Q Lebanon. Okay, let's go to the 2026 roadmap. Our main goals is to make advanced real world quantum impact. Sorry, let's zoom that text. To apply this theoretical quantum computation on real world projects and make students able to see where their learnings are going on. And second of all, we want to strengthen global quantum collaboration. We want to have multiple collaborations events with different QCousins and other organizations. And first of all, engage students through universities, outreach, and introductory sessions on quantum in different universities in Lebanon. Okay, we will go with the first event that's planned for this year. And after discussion with Q Saudi Arabia and Q Poland, we will be moving with Triple Q workshop. This workshop is mainly focusing on quantum machine learning and quantum real-world application. After our first Q Bronze, many of students reached out to us in order to see where they want to apply their knowledge, their new knowledge of quantum. So we will be doing this workshop with Q Saudi Arabia and Q Poland. This will be mainly focusing on quantum machine learning. We will have different assignments, and at the end we will have a project. The main agenda for this event is not done yet. Once it's done, I will have a discussion with the Q Saudi Arabia team and Q Poland team if they have any comment, anything, and we will be moving with it. Okay, sorry. With the second event for this year, we will be launching the quantum paper discussion series. Basically, every 2 to 3 weeks, we will be discussing a quantum paper on a live session with the students in Q Lebanon. We will choose a quantum paper, and maybe we will have a professor to discuss it with us, to explain it, to like make it more easier for students to start reading the newly researched papers. So this will be a series every 2-3 weeks. We will have a meeting discussing a quantum paper. And with the third event, we will hopefully be launching our Q Silver workshop according to the agenda of QWorld and the materials. So we will be planning to do our Q Silver workshop. And at the end, as I mentioned, we have our main goal, which is to increase the number of members of Q Lebanon. We are now 5. We are reaching out to new students to be a part of our team. And also we are reaching out universities, professors and ambassadors, so we can sometimes give an introductory sessions in universities for students who don't know yet what is quantum computation, or what is the future of quantum computation, and everything related to that. And also we will do, as I said, multiple of collaboration, especially with different QCousins and also with organization that supports women in tech, which we will have with them a couple of events. And that's it for Q Lebanon. Thank you so much, and please, if anyone have a question, let me know.
Thank you so much for your presentation.
Thank you. May I just have a comment?
Yeah.
I really like this ambition and also the way that you're organizing yourself. I think it would be I don't know if especially if you have online events. I think it would be very good if QWorld could advertise this within the QWorld network, so it's not only the Q Lebanon or the region, but everyone can attend. I mainly think about these paper sessions that you plan to do, and then depending on how it goes, it can become like an official Q World series, whatever. I mean, but I think what we can do is we can support these local events is that we can bring more audience.
Yeah, definitely. We want to try a couple of sessions first if it went well and as we planned. So definitely we will be moving it to global QCousins and like we international.
Yeah, cool.
Thank you, Errol, for your comment, and thank you, Ali Ibrahim, for the presentation. Let me ask again if there is any representative from the Q Cameron present, then they are welcome to present. Okay, I believe we do not have anyone from the Q Cameron, so over to you, Paul.
Okay, thanks, Harsh. We do not have anyone from Q Cameroon, unfortunately, but I can also tell you that in the meanwhile, we've agreed with members of Q Tunisia that they will give a talk tomorrow, probably at the end of the day. We are also not sure about Q Iran. We are not sure if they have internet access, so we are not sure if they will be able to present their Q cousin. If not, then maybe Q Tunisia will present then. We'll also try to contact Q Cameron and we'll see. Maybe they'll be also able to give a presentation tomorrow. But for now, we are just planning to go according to the scheduled agenda. So this is almost the end of the first day of our QWorld annual meeting. So thanks for staying with us. And the last point in the agenda for today is the breakout room session. So it should start in 12 minutes, but actually, if you do not mind, I think we can start it earlier because this is already the last session. And I know that people should be able to join us later. Alternatively, we can just do a break, but if we already have all the moderators, then I think we can start the breakout session earlier. Let me just check our Q&A. Okay, there was just a question about QInter. So is it fine for everyone to start the breakout room session now, or do you prefer to have a break and start in 12 minutes from now, according to the schedule? I will also ask the moderators, Harsh, Shalini, and Omid. Let me know what you think and if you are ready or you prefer to take a break.
I think we can go ahead.
Okay, we can go ahead. All right. Okay, so now we'll create three breakout rooms. Yeah, there's a comment from Juliana. Thanks, Juliana. We'll create three rooms. The first one will be focused on quantum technologies, and Amit will be the moderator. The second one about organizing workshops and events together in 2026, and this will be moderated together by Shalini and Harsh, and I will moderate the third breakout room in which we'll talk how to organize, lead, and improve QWorld and QCousins. Okay, so let me just try to create these rooms. So now I have a question to Omin, because I see that we have these 3 breakout rooms prepared. I can just open them, and I understand that our participants should be able to just select one room they would like to join. Is that correct?
Yeah, but maybe just for clarification, maybe we can quickly rename room, because it's room 1, room 2, and room 3. Maybe we
Yeah,
can
I
quickly
agree. I
rename.
agree.
All right.
Okay, let me just rename
Yeah.
breakout rooms. So there's the first one about quantum technologies, another one about organizing workshops and events together,
Yes.
and another one about
By the way,
QWorld.
Abdul Malik is helping me for the
Mhm.
moderating stuff today. Yeah, because I'm not sure that my internet is
don't worry,
stable
man. You
enough.
got it.
Okay. Thank you.
Okay, Abdul Malik will have. Okay, good.
Yeah.
Thanks, Abdul Malik.
Uh,
All right, QWorld and QCousins. Okay, so I've just renamed the rooms, and I think you can start them now. All right, so let's try to do it.
okay, thank you. I think we can join, right?
Yes,
Okay,
I think that
so
everyone should be able to join the preferred breakout room, but let's see if you can do it.
okay, I'm gonna jump now and see what you can do to sign.
So we should say goodbye now for today.
Yes, goodbye. So
Right.
actually, everyone can also switch the rooms later, right? If we have time. But
Okay.
indeed, I would like to thank everyone for attending today, and both the speakers and participants. And let's meet tomorrow as well.
Yeah.
Tomorrow
See you
we'll
tomorrow,
start
and
half an hour later, but for now,
All
let's
right.
just continue our discussions. See you soon in the breakout rooms.
Cool. Okay.
Hello, everyone. It seems that we forgot to enable that you can go to this meeting rooms. Now it should be available. So to join a meeting room, you might need to click on the three dots, depending on how large is your window, and then you will see the item called breakout rooms. There's some, to me it shows there's a red number 11. So when you click there, you are able to see, you're gonna see the list of waiting rooms. I guess you will see who is in there, although I have a co-host, right? So might see somehow differently. The only thing is that is a little bit less intuitive is that if you come back to the main, like the main session, then you have to click on the leave button. But I guess no one's going to stay here. Everyone is going to go to some of the meeting rooms very soon. Is it clear, or should I repeat something?